Assalamualaikum and good day. My name is Muhammad Al-Rashid bin Anhar and my metric number is 230050038. So on today's KIB1016 video assignment, I will be presenting on how to do an AC analysis regarding the BGT analysis. So for this particular assignment, I have been given 5 questions in total, A, B, C, D and E. And for this particular assignment, I will be using the last 3 digits of my metric number that will be replacing the beta value here. So later on, the beta value will be included in the calculation part. Okay, so the first question, perform DC analysis to calculate the DC operating point, VCEQ and ICQ. So straight at the circuit, I can identify that this part of the circuit is the input part and this side of the circuit is the output part. Later on the solution part, there will be a simplified version of the circuit in order for us to easily do an analysis regarding the SE analysis. So since the first question asks us to perform DC analysis, for my solution, I would redraw the circuit back because it will be easier for me to later on pick out all the important information so it won't be left out. So first step is to find the Thevenin resistance, which is the RTH. So since it asks us to do DC analysis, I will be assuming capacitors will be open circuit. So this is the simplified version of the original circuit. So since here we got a capacitor here, so it will then be an open circuit. So this part of the circuit will be eliminated and 1 kilo ohm will be ignored. So also at this part of the circuit, since we do have a capacitor here, it will also be open circuit and it will also be eliminated as well. So to find the RTH, we only have to reconsider these two resistors, which is the R1 and also R2. So to find the RTH, since R1 and R2 is in parallel, we can straight away find the RTH. 100 kilo ohm times 25 kilo ohms over 100 kilo ohms plus 25 kilo ohms. Then we get 20 kilo ohms. Okay, then we have to find the Thevenin resistance. So the Thevenin resistance, we have a formula here, VCC times R2 over R1 plus R2. This is the voltage divider rule. So in order for us to find the VTH, VCC here is VCC and then R2 here over R1 plus R2. So we can straight away find the VTH here, 3 volt. Okay, moving on, we have to use the Kirchhoff voltage rule in order for us to find the IB. Okay, these are the important formula that needed to be understood of. So from my understanding, the only current that is important for us to find that is included in the DC analysis is the IB. If we have find the IB, we can straight away find the IE and IC, since IB is included in all formula to find the IE and also IC. If you can see here, if we have the IB value, we can straight away find the IC and also IE, since they both have IB in its formula. So using KVL, we can say that VTH minus IB times RTH minus VBE minus IE times RE equals to 0. Okay, then we can say that we can replace the IE here to equalize the IB here to make the same unknowns, since we already have VTH, RTH and also RE. we can straight away replace the IE with beta plus 1 times IB here. So then furthermore, on the calculation, we can see that the IB value is 3.83 times 10 to the power of negative 5 ampere. So since we have the IB value, we can straight away find the IC value. IC in its formula is equals to beta times IB. Since my beta is 38 and my IB is 3.83 times 10 to the power of negative 5, I can straight away find the IC value, which is 1.45 milliampere, which is equivalent to ICQ. Okay, we found the first answer to our question, which is to find the ICQ. So move on to finding the VCEQ. Okay, so to find the VCEQ, we have to use another loop to find the VCEQ. Okay, from first of all, we have to find the IE, which is in its formula, which is beta plus 1 times IB. We do have the IB value. So beta plus 1 is 38 plus 1. We got 39. Then we have to times the IB value. IB value here we have 3.83 times 10 to the power of negative 5. We got 1.5 milliampere. Okay. Finding another loop, we can see that VCC minus IC RC minus VCEQ minus IE RE equals to 0. Okay. We can replace the VCC with the value itself, 15 minus IC 1.45 times 10 to the power of negative 3 times 2.2 times 10 to the power of 3 minus VCEQ minus 1.5 times 10 to the power of negative 3 times 1k equals to 0. Then we can straight away find the VCEQ, which is 10.31 volt. Okay. Moving on to the second question, which is perform AC analysis to calculate the small signal parameters GM and RPE. So since we have to undergo AC analysis, we have to consider another rule, which is capacitors are being short-circuited and the DC sources are then grounded. So I will redraw back the circuit back. Here is the original circuit. So we have first to find the RE, which is equivalent to RPE. RE is VT over IE. Since VT is constant, which is 25.9 times 10 to the power of negative 3 over 1.5 times 10 to the power of negative 3, we got 17.27 ohms. Okay, then we have to find a GM, which is in its formula is IC over VT. So IC, since we have calculated it earlier, is 1.45 times 10 to the power of negative 3 over 25.9 times 10 to the power of negative 3. Therefore, we got our GM value, which is 56 milliampere over volt. Okay. Moving on to the third question, which is sketch the small signal equivalent circuit for the amplifier, which is earlier when I said that we have to make a simplified version of the original circuit. This is the simplified version of the circuit that we have to do the analysis on, since we already done the AC analysis. So on this side of the circuit is the input part, and this side of the circuit is the output part. This version of the circuit will make it more easier for us to later on identify on which part we have to do the analysis on, rather than we refer to the original circuit. Okay. For the last question, we have question, or to calculate the small signal voltage gain for the amplifier. So from the formula, we can say that the voltage gain is V out over V in. Since V out is equals to negative GM times RTH, and also times the RC parallel with RL, from the simplified version of our circuit here, we can say that when RC parallel with RL, we found a value which is 1.8 kilo ohm. Sorry, here is kilo ohm. Okay, when we did find the RC in parallel with RL, we can straight away include it in the formula for finding the V out. Then we got the answer negative 2,620,800. That's for V out, and for V in is only the formula for RS plus RTH. Then we can straight away find that the V gain is negative 124.8, and it got no value since it will then cancel out in the formula later on, in the formula included here. So I think that's all for the questions. Thank you.